Namaskar. Today's video is about a pollutant emitting area source situated at simple flat terrain. Consider a square area of 200 meter into 200 meter that emits pollutants 5 meter above ground at a rate of 100 gram per second per meter square. If the terrain is simple and flat and dispersion coefficient is urban, then calculate the maximum pollutant concentration and its distance from the source when automated distances of 50 meter to 1000 meter are used. And second, the maximum pollutant concentration at 5 kilometer, 10 kilometer, 20 kilometer and 15 kilometer from the source. And note here that set yes for the option search through range of wind direction and keep all other set to default or no or unchecked. However, this search through range of wind direction, if we select yes, this is the default option. So we have to discuss this search through range of wind direction. Since the concentration of a particular distance downwind from a rectangle area is dependent on the orientation of the area relative to the wind direction, the screen model provides the user to opt option from the two options, it is yes or no, for treating wind direction. By selecting the option yes, the screen model will search through a range of wind directions to find the maximum concentration. And the regulatory default option, this is the regulatory default option and should be used for most applications. But if we select no, then wind direction related to long dimension, this option become available, and we have to specify a wind direction orientation relative to long axis of the rectangular area. There is another parameter definition. Option is a search release height. This means we have to specify the source release height. So here we have to specify the source release height above ground. So in this particular, in our problem, it is 5 meter. We have to specify this option as 5 meter. So this is my screen view. So I going to solve this problem. I first open my project and specify the information. So this area source urban and flagpole receptor is 0 is selected, and all the source area parameters is selected. Search through this option is yes. If we select no, then this option will appear and we have to input the direction of wind here. And this is the source release height, we have to put 5 meter. Hit next. The terrain option is simple terrain flat, and we have to opt these two automated distance and discrete distances. Meteorology is full meteorology, and keep all other option as default. Now I hit next button. Automated distance, here we put minimum distance is 50 meter and maximum distance is 1000 meter. And for discrete distance option, 5 kilometer, 10 kilometer, 20 kilometer and 15 kilometer are selected. Then hit next and these windows appear. So project is complete. So I hit run option and then see the graph. So this is the first graph. This is automated distance versus concentration. You can see that up to 200 meter the concentration is increases, then the concentration is decreasing mode up to 1 kilometer of this automated distance versus concentration graph. Now we have to see the discrete distance versus concentration from 5 kilometer, 10 kilometer, 20 kilometer and 15 kilometer. We will see that the concentration is decreasing. Now I have to open the output file. So this is our output file. This is the simple train option is given here, and this is the automated distance from 50 meter to 1000 meter of 100 meter array. The concentration of all points is given, but the maximum concentration is at 168 meter, and the concentration is 0.61 0.1671 into 10 to the power 10. And for the all discrete distance options, that is from 5 kilometer away from the source, the concentration is 0.287 into 10 to the power 8. 10 kilometers away, it is 0.1285 into 10 to the power 8. For 20 kilometer, it is 0.6016 into 10 to the power 7, and at 50 kilometer away from the source, it is 0.285 into 10 to the power 7. So first, the question of our the first question's answer is this, and the second, for the second part of the question, is the answer is this. Thank you for watching this video.